I'm here to present today on Strategic Metals Hopper project, which is located in west central Yukon. We feel that the project is ready for resource definition, but it presents tremendous upside potential for further discovery.
Before we begin, this is a technical presentation, so we will be making some forward-looking statements. Comparisons with certain other mines and deposits are for geological reference only. Strategic Metals recently regained 100% interest in the road-accessible Hopper Copper Gold project. It hosts significant porphyry copper mineralization at the Hopkins North target that's largely untested by drilling, and gold-enriched skarn mineralization at the Copper Castle target that remains open along strike and down dip. In 2021 and 2022, partner-funded drilling returned some of the best drill intercepts on the project to date, with highlights of 1.87% copper and 1 gram per ton gold over 15 meters at Copper Castle, and 0.22% copper over 114 meters from surface at Hopkins North. We're more excited because, as I will demonstrate, both these drill holes are proof of concept. They represent bold step-outs into areas undercover, and it's one of the reasons we think discovery potential on the project remains very high. So let's go through the project from start to finish. The Hopper is located in the Yukon, which is consistently ranked as one of the most attractive jurisdictions in the world for mining companies. It lies about 180 kilometers northwest of Whitehorse and 320 kilometers north of Haines, Alaska, the closest deep-sea port. The project is road accessible via the Aishihik Lake Road, which meets the Alaska Highway west of Whitehorse, and it covers a 74 square kilometer area with a network of access roads and trails. A hydroelectric dam is installed at the south end of Aishihik Lake, 22 kilometers south of Hopper, where water is diverted from above Otter Falls to generate a major source of hydroelectric power for the Yukon. The project lies within the southern part of the Dawson Range Gold Belt, a metallogenic province of west central Yukon that hosts several major copper and gold deposits, including the Tier 1 Casino Copper Gold Deposit, the Coffee Gold Deposit, the Claza Gold Silver Deposit, and the Nucleus and Revenue Copper and Gold Deposits. In the following slides, I'll briefly touch on Casino and on the Whitehorse Copper Belt, as we believe the Hopper shares many similarities with these two systems. The Casino deposit, 190 kilometers northwest of Hopper, was discovered in 1969, and it's situated in the same tectonic setting as Hopper. It covers the Late Cretaceous age patent porphyry intrusion and surrounding breccia, which hosts a combined 7.6 billion pounds of copper and 14.8 million ounces of gold. The project's owned by Western Copper and Gold, with large shareholdings by Rio Tinto and Mitsubishi Materials Corporation, formerly known as Mitsubishi Metals. Immediately outside of Whitehorse, the Whitehorse Copper Belt consists of more than 30 copper-gold skarn occurrences over a 30-kilometer long trend. Mineralized skarns form on or near the contact between the mid-Cretaceous Whitehorse Suite granitic and dioritic rocks and Triassic age volcanic and sedimentary rocks of the Lewis River Group. Ore bodies occur mainly within limestone members of the Lewis River Group, adjacent to or within a few hundred feet of the diorite contacts. 6 open-pit excavations were mined between 1960 and 1982, and the economic influence of the copper mines had a transformative impact on the community of Whitehorse. The past producers, with the largest being the Little Chief Mine, were operated by Whitehorse Copper Mines, which had financing from Sumitomo Metal Mining, Hudson Bay Mining, and Anglo American. The total mine production from 1967 to 1982 was 8.54 million tons, and with reported grades of 1.53% copper and 0.75 grams per ton gold. Hopper has a similarly long but far less intensive history of exploration over its 3 main zones from north to south: the Northern Skarn, Hopkins North, and Copper Castle. The first documented work was performed at the turn of the century by prospectors that discovered copper mineralization in Franklin Creek, pictured here on the right. In the late 60s, Mitsubishi Metal Corporation was the operator and focused their attention on the Hopkins North porphyry potential, and this included chip samples and bulldozer trenches that returned 0.25% copper over 61 meters and 0.52% copper over 46 meters. The first Hopper drill program was launched in 1977 while the project was under option by Whitehorse Copper Mines, and between 1977 and 1989, 3 rounds of drilling were performed. I'll walk through these programs as we go here. Whitehorse Copper successfully intersected skarn mineralization in the uppermost horizon of Copper Castle, which yielded 1.94% copper and 0.87 grams per ton gold over 18.6 meters. Reconnaissance holes that were collared about 700 meters away further up Franklin Creek cut narrower intersections of skarn with results of 1.38% copper over 0.45 meters, but it's important to note that holes were selectively sampled, so this represents only a half a meter of a possibly wider zone. We're missing that data. Likewise, sample details and individual assays are not available for the 1980 percussion drill program because the original report can't be located, but the highlights were documented in subsequent reports. We do know that the chips were not logged and only copper was analyzed and not in all holes. But despite these limitations, highlight results from 1979 to 1981 include 1.52% copper over 18.3 meters on Franklin Creek. And note the significant intercept on the left bank of Franklin Creek, 0.24% copper over 15.3 meters, which represents the southernmost drill intercept of the Copper Castle system to date. The system still remains open in that direction. Between 1981 and 1985, the project was orphaned due to low commodity prices. A small drill program was completed in 1989 by Kazao Exploration Ltd. The strongest results were from the holes on the left bank of Franklin Creek and included 1.98% copper and 0.67 grams per ton gold over 7.79 meters. Strategic's interest in Hopper started in 2006 when the company restaked the area surrounding Franklin Creek, which was then a small claim holding by an independent prospector. The company quickly got to work doing detailed geological investigations before finding a partner who performed 1,309 meters of diamond drilling in 6 holes and 1,731 meters of reverse circulation drilling in 58 holes. Diamond drilling in 2011 was largely confirmatory, but deeper than the previous rounds, identifying strong gold values in the deeper portions of the skarn. Widely spaced reverse circulation drill holes explored beneath overburden in parts of the till-covered plateau. And the holes stopped at or above bedrock, so they're essentially testing the superficial material above the Hopkins North for anomalous copper, gold, and molybdenum. The holes did return elevated metal values, including 0.24% copper over 39.62 meters, which is the entire length of that hole, and 0.36% copper over 9.15 meters. Several of the RC holes bottomed in mineralization, and this data has been instrumental in follow-up programs to help vector towards porphyry-type mineralization. Between 2012 and 2014, Strategic undertook a series of summer programs at Hopper just to better understand the size and geometry of the system and prepare for future rounds of drilling. Soil samplers working in rougher country off of the plateau and down in some thick brush identified more skarn showings on the project than were previously recognized, so lots of boots on the ground work still yields discoveries. One of these discoveries here is pictured on the right. This culminated in the first ever diamond drill holes that were directed towards the porphyry target in 2015, yielding 0.17% copper over 162.85 meters. As you can see, drilling at Copper Castle was very widely spaced that year and was designed to test new targets and targets deeper in the system. We discovered more strongly gold-enriched skarn mineralization at depth, where results include 12.15 grams per ton gold over 2.65 meters and 43.6 grams per ton gold over 1 meter. 2016 saw another widely spaced diamond drill campaign at Copper Castle, managed again by Strategic Metals. None of the drilling was directed towards the showings in Franklin Creek, but instead tested geological hypotheses along the system, which now represented a 1,200 meter long strike length and 425 meters of vertical extent. In the spring of 2021, Strategic Metals optioned the project to Cavu Mining, who through a future transaction would become Alpha Copper Corp, and Cavu drilled 6 diamond drill holes on the project. 3 of the holes progressively tested an electromagnetic conductor from northwest to southeast on the left bank of Franklin Creek, and all 3 cut massive to semi-massive sulfide mineralization, including a highlight intercept of 1.41% copper and half a gram per ton gold over 22.28 meters. 1 hole tested Hopkins North and successfully intersected porphyry-type mineralization, yielding 0.22% copper over 114.38 meters from surface. In 2022, Cavu returned, and they performed 2,327.45 meters of diamond drilling in 8 holes, with holes targeting the EM conductor continuing to intersect strong mineralization, such as 1.87% copper and 1 gram per ton gold over 15 meters. 3 holes were directed towards the Hopkins North porphyry, encountering widespread intervals of copper, gold, silver, molybdenum mineralization, including 0.12% copper over 214 meters from surface and 0.11% copper over 306.75 meters, including a narrow interval of 0.44% copper over 15.56 meters from a hole. This is called 400 meters to the northeast. In summary, the work history at Hopper includes 3,100 soil samples, covering about 30% of the project area. Airborne electromagnetic and magnetic survey coverage over the entire property, with VLF EM coverage over Copper Castle, Hopkins North, and the northern skarn targets. 3D-induced polarization surveying over Hopkins North and a northern skarn, which is approximately 15% of the property area.
and about 20% of the project is mapped in detail. In addition, there's been 4,220 meters of shallow percussion drilling performed in 104 holes, and a total of 12,300 meters of diamond drilling completed in 56 holes. About 29 kilometers of historical road and trail building has been performed on the project, and Hopper is drill permitted for a large drill program. The regional geology here is characterized by Devonian and older snowcap assemblage, metasedimentary, metavolcanic, and rare metaplutonic rocks, primarily micaceous schists, quartzites, gneiss, and marble. In this map, snowcap assemblage rocks are illustrated as the cooler colors, which occur as a northwest trending belt along Aishihik Lake. Unconformably overlying snowcap assemblage rocks is the Paleogene Rhyolite Creek volcano-plutonic complex, which is exposed in small volcanic centers east and north of Long Lake. Rocks of the early Jurassic Long Lake Suite make up the extensive Aishihik Lake batholith, which is represented as the honey yellow color covering the northeast corner of the map. The suite is multi-phase, ranging from diorite to granite, with granodiorite being dominant, and is foliated here in contact with the Paleozoic rocks. Central to the property is the Hopper Pluton, which is a multi-phase intrusion with compositions ranging from granodiorite to quartz diorite and rare diorite. In recent years, age dating of the Hopper Pluton has repeatedly demonstrated that it is Casino-aged, linking it with other important Late Cretaceous copper and gold deposits across the Dawson Range Belt, including the previously mentioned Casino copper-gold porphyry deposit. Outboard of the Hopper Pluton, north to northeast striking porphyry dikes, informally known as the Aishihik dikes, have been radiogenically dated to the Casino suite as well, and their thicknesses range from about 1 meter to 50 meters in width. The main foliation in the area strikes northwest and dips moderately to the northeast. Folds associated with the main foliation trend northwest and are tight to isoclinal and overturned to the northeast, illustrated here in image C. A later regional folding event affects all the older structures. Folds associated with this event are open and plunge shallowly to moderately to the north and northeast. These are observed indirectly as a change in orientation of the earlier structures. Large north to northeast striking brittle faults are observed across the region, characterized by zones several tens of meters wide forming linear topographic features. Very few reliable kinematic indicators are observed on any of these faults. Known skarn mineralization occurs near the contacts of the western portion of the Hopper Pluton, at the Copper Castle and northern skarn targets. However, I would note that the eastern portion of the Pluton is under quaternary cover and is just untested. Skarn development progresses along a typical pathway. Firstly, some hornfelsing and isochemical reaction skarn forms early, with some minor mass transfer between the marble, schist, and quartzite stratigraphy. Second, we see some endoskarn development into dikes, to a greater proportion as you move closer towards the contact with the Hopper Pluton. This is characterized by the alteration of plagioclase to sericite and chlorite, and the alteration of the ground mass to iron oxides. And then next we see prograde exoskarn, which is characterized by garnet and diopside replacement of the marble beds, with higher concentrations of garnet closer to the Pluton and grading outward to predominantly diopside skarn. Overprinting diopside is semi-massive magnetite and lesser pyrrhotite mineralization. Depicted third in the image here is overprinting retrograde skarn as the thermal regime collapses, and this is marked by the occurrence of actinolite and tremolite largely replacing the earlier diopside. As the system cools further, late skarn formation is marked by the occurrence of wollastonite, vesuvianite, and talc, partially replacing actinolite, tremolite, or occurring as late serpentine talc carbonate veins. The observed paragenetic sequences at the Hopper project and the Whitehorse copper deposits are very similar. Chalcopyrite formation occurs during the initial stages of retrograde skarn formation, with chalcopyrite replacing magnetite. Electrum, bismuthinite, and a mixture of bismuth and silver tellurides subsequently precipitate as minute blebs or fracture fillings within chalcopyrite during a second stage of retrograde skarn alteration. Gold is associated with late chloroactinolite retrograde alteration, and that appears to be controlled by fault zones. Historical work at Hopper was focused on mineralization at the Copper Castle target, which outcrops along steep west-facing topography. Several mineralized skarn horizons are observable from surface in Franklin Creek and north to the contact with the Hopper Pluton. And the skarn horizons range from about 2 to 20 meters wide and are shallowly east dipping at about 15 degrees. Drilling by Strategic Metals and prior operators identified at least 11 of these horizons to a known vertical extent of 425 meters. This is simply the limits of the deepest holes directed towards Copper Castle to date. Calcareous horizons, or their altered equivalents, collectively comprise about half of snowcap assemblage
between the Hopper Pluton and Franklin Creek, an area which covers a strike length of 1,200 meters and a known cross-sectional extent of about 800 meters. You can see here a variety of steeply dipping, north-trending porphyry, diorite, and lamprey dikes that are all related to the 78 to 76 MA Hopper event. The dikes are weakly mineralized and occur pre, post, and syn mineralization, likely exploiting brittle faults that evidently have seen little displacement. Skarn mineralization can be notorious for complicated geometry, but the configuration that we find at Copper Castle is relatively straightforward. Highlighting cross-sections from the south, starting with C to C' and Franklin Creek, we see broad copper-gold intervals in the uppermost known skarn horizons, which remain open down dip. Looking at the orientations of the drilled skarn here, there's some evidence of tight, overturned folding, which could represent a structural thickening of the stratigraphy. Next, we'll take a look at section B to B', 100 meters to the north, where we see high gold grades in the number 11 horizon, the deepest skarn recognized on the project to date. And finally, I'll present the section A to A', about 400 meters further to the north, where the drill density is far less than the area around Franklin Creek, and the exact controls on mineralization are not fully understood, but nevertheless, gold grades again appear to be strongly enriched in the number 11 skarn. North of Copper Castle, the Hopkins North target covers porphyry veining, alteration, and associated copper-gold molybdenum mineralization within a 2.3 km by 650 meter area which covers the Hopper Pluton. The best porphyry intersections at Hopkins North to date comprise chlorite-altered monzonite and porphyry dikes with zones of vein-controlled potassic alteration, indicating proximity to an untested, higher-temperature porphyry center. Note here that a single diamond drill hole has tested the skarn mineralization at the northern skarn target, which covers snowcap assemblage stratigraphy that is a mirror image of Copper Castle. This area has seen radically less work directed towards it than Copper Castle, but it presents a strong target for future drill testing. IP surveying in 2015 over the Hopkins North porphyry target identified several areas of strong chargeability, coincident with copper and soil geochemical anomalies suggestive of sulfide mineralization. Much of the prospective area is heavily vegetated and blanketed by various depths of overburden, and the target is considered to be at a very early exploration stage, having been tested by very few diamond drill holes. Soil sampling on the property has outlined a 3.6 km long by 1 km wide, mostly greater than 100 ppm copper and soil anomaly encompassing all three targets. Parts of the copper anomaly are accompanied by clusters of high gold, silver, and molybdenum values, the strongest of which occur along the escarpment at the western edge of the property, where overburden is thin and soil development is endemic, hence the two populations here with differing geochemical thresholds on the image shown. In summary, the Copper Castle target at Hopper remains open to expansion along strike and down dip, while its full stratigraphic thickness remains untested. Mineralization in the skarn is associated with the multi-phase Hopper Pluton, dated at 78 to 76 MA, a date that places Hopper in the same metallogenic episode as the Casino copper-gold porphyry deposit. The Hopkins North porphyry target covers porphyry veining, alteration, and copper-gold molybdenum mineralization, and remains drastically underexplored. Strong geochemical and electromagnetic anomalies on the property present compelling drill targets. For more information, please visit strategicmetalsltd.com.